that we know how to simplify our radicals, we're going to add and subtract our radicals because we need to know how to do operations with them. Okay? When we're adding and subtracting radicals, it's very similar to how we add and subtract polynomials. We combine like terms. So with our radicals, they have to be like radicals. So that means that the radicand and the index is the same. Okay, so basically what's under the root and what kind of root it is the same. They have to be the same. So remember, this is our radical. This thing underneath is called the radicand. This thing here is called the index. And remember, if there's nothing there for the index, it's an unsaid 2. Okay? So you can combine these two because they're both square roots and have a 3 underneath. However, you cannot combine these two because this is a cube root and this is a square root, so they have different indexes. Okay? So what you want to do when you're adding and subtracting is you can simplify first and then you add or subtract like radicals from there. Okay? So what happens with our radical is that it functions kind of like a variable, right? So here, this would be similar to 2x plus 5x, right? And we add the coefficients, so 2 plus the 5 gives us 7x, okay? Now here, there's not any simplifying with the root that I need to do. I can't break it down any further. So all I'm going to do is I'm going to take the 2 and the 3, and the 2 and the 5, and I'm going to add those two together. And then it's the thing that we're adding is the root 3's. So this would be 7 root 3. So if you have 2 blue shirts and I have 5 blue shirts, that means together we have 7 blue shirts. So the root 3 is acting like a variable. We're saying that they're like terms because they have the same kind of root, so they're both square roots, and then they have the same thing underneath. Okay? So, and again, you add and subtract the same way. So here, with the subtract, there's nothing to distribute in this case, so I don't need to worry about distributing. But when I'm subtracting, I just need to make sure that I subtract the two coefficients. I look to see, are these like terms? Well, this is square root and square root. This is a 3 and a 3, so the radicand and the index match on both of them. So then I subtract. So I do 4 minus 7, and then the kind of thing it is a root 3. So we do 4 minus 7 is negative 3 root 3. So then that becomes our answer. Okay. Now in this next one, if we look, we've got a square root and a square root, which is great, but we have a 3 and a 75, so I cannot add them. So what we can do though is we can simplify the radical first. So remember, we're breaking down our radicals. So if we break down 75, that's 25 and 3, and if we break down 25, that's 5 and 5. So we have a pair of 5's and then a loner 3. So this one, don't forget to bring the 2 out. Right, so we're adding 2, or not bring the 2 out, bring the 2 down is what I was trying to say. And then the 5 comes out because there's a pair of them. Remember, it's a square root, so we want 2, and it comes out as 1, 2 people, 1 date. And then underneath, there's still a root 3. And then we still have this guy right here, right? There's nothing I can do with that one to simplify it because root 3 is prime, so there's no pairs, nothing can be pulled out. So then what I'm going to do is I'm going to multiply these two numbers here, so then that gives us 5 root 3 plus 10 root 3. And now, if I look again, now I have square root and square root still, but now my radicands, or the thing underneath, is the same. So the root 3's are the same, so I do the 5 plus the 10, which gives us 15, and they're root 3's. Okay? Now, not everything is root 3's. Okay, the first 3 examples were with root 3's, but there can be other ones. So if we take a look at this next one, notice there's no like terms to begin with. You can see if there's like terms originally, and then try and add them together, and then break down and go from there. But oftentimes there's not any like terms to begin with. So what we have to do is we have to simplify the radicals. Okay, so here, 8 breaks down to 4 and 2, 4 breaks down to 2 and 2. So that means I have a pair of 2's that come out. We don't want to forget the 5 that's out in front already. The things that come out get multiplied by what's out in front, so 5 times the 2, and then underneath we have a 2 left over. Okay? So we're going to do the same kind of thing here. So I'm going to bring down the negative 4 before I accidentally forget about it. 18 is 6 and 3, or remember if you do 2 and 9, that when you're breaking it down to its prime numbers, it doesn't matter how you break it down, everybody will end up at the same spot with the same prime numbers, sets of prime numbers. So this is 2 and 3, so we have a pair of 3s. Again, we're looking for pairs because this is an unsaid 2. So we've got a 3 comes out and then a 2 stays underneath. And then root 3, I can't do anything with it, so I just keep it as is. So I'm going to finish simplifying by multiplying these things that are out in front. So we have 10 root 2 minus 12 root 2 plus root 3. So now we look for like radicals. Remember, like radicals have the same kind of root, so they all are square roots, and then the same thing underneath. Well, these two have the same thing underneath, but this one doesn't. So I can combine these two, but not this one. So I'm going to do the 10 minus the 12, which gives us negative 2 root 2, and then add root 3. And I can't do anything past that because these are not like terms. So this would be like adding an x and a y. We just leave them as is. Okay. So I'm going to give you a minute. Let's skip over to this one here, and then we'll take a look at this one together. So I'm going to give you a little bit of time to take a look at that one. So you can pause the video, try it out, see what you come up with. Okay, so you should have paused the video. Now it's time to go back. So if I break down 18, we've got 9 and 2, and then 3 and 3. So I've got a pair of 3s. This negative 3 stays out in front. We bring out the pair as 1, 2 people, 1 date, and the 2 stays underneath. 8 is 4 times 2, 2 times 2, so the 3 I keep out, so plus 3. A pair of the 2's comes out as 1, and then the loner 2 has to stay underneath. Doesn't have anybody to go out on a date with. We do 6 and 4 for 24. That's 2 and 3, 2 and 2. So I have a pair of 2's and a loner 2 and a loner 3. So, sorry. So we have the negative that comes out, or that's out in front that we need to not forget about. The 2 comes out, and then underneath we have a 2 times a 3. So this gives us negative 3 times 3 gives us negative 9 root 2. And then we do 3 times 2 root 2, so plus 6 root 2. And then we've got minus 2 root, and then the thing that's multiplying is underneath in this case, so 2 root 6. So minus 2 root 6. Okay. So then I'm going to look. We've got root 2's here and a root 6 here. So these two are like terms because they are both square roots and have 2's underneath. So we do negative 9 plus 6, which gives us negative 3 root 2, and then minus 2 root 6. Okay. Let's look at what we do when with something other than a square root. It's exactly the same pattern, except for when we're breaking down our roots, we need to follow the pattern for whatever kind of root it is. So in this case, since they are cube roots, we need groups of 3 in order to get out of the radical. Okay? So, but the way that we do it other than that is exactly the same. So 40 is 4 and 10, 2 and 2, 2 and 5. And again, we need groups of 3. So make sure you're paying attention to that 3. We need groups of 3. So here I have a group of 3. It comes out, and then we are left with the 5. And don't forget to write the cube root there. That just was horrible. Let's just try that again. So the 2 comes out, and then we have the cube root of 5. So don't forget that you need to write your index still in this to show that it's a cube root that you were talking about. Okay, 5 is prime, so I can't do anything, so I'm just going to bring this down as is. So 3 minus 3 cube root of 5. And then if I break down 135, I know that since it ends in 5, it's divisible by 5. So if we do 135 divided by 5, it gives us 27. 27 is 9 and 3, 9 is 3 and 3. So we have a group of 3's. Right? Again, we want groups of 3. So when I bring this out, we're going to have plus, well, I'm going to write it down a little bit further because I'm out of space there. So plus the 2 that was already out there times the 3 that's coming out, and then cube root of 5. Right? So these can still be 2 cube root of 5 minus 3 cube root of 5. And then this turns into really 6 cube root of 5. So I'm just going to write 6 below it. So these are all cube roots of 5. So since they're all cube roots and they all have a radicand of 5, I can add all of them together. So we're going to do 2 minus 3, which is negative 1. Negative 1 plus the 6 gives us 5. So we have 5 cube root of 5. Okay. So it's exactly the same pattern that we use before, except for when you're breaking it down, you're just breaking it down based off of the index, and you need groups of 3 for a cube root, groups of 4 for a fourth root, groups of 5 for a fifth root, and so on and so forth. So you need to remember, like radicals have to have the same kind of root, so square roots with square roots, cube roots with cube roots, so on and so forth, and the same radicand, so the same thing underneath. Okay? So that's why these two are not added together, because the radicand is different. Okay? So that's how we add and subtract our radicals, by finding our like radicals or our common terms by breaking down the radicals.